Hey guys, hope you guys enjoyed your spring break. And when we last left off, we were doing radicals, all right? And now we're going to be solving equations, all right? Either where in order to solve it, we're going to have to solve by taking a radical, or the equation is going to have radicals. So we're going to split this section up into 2 days of notes just to kind of make it a little bit easier, ease yourself back into it from spring break. And then we'll do a day of review, and then we will have a little quiz. All right, so 4 total days: 2 days notes, 1 day review, and 1 day quiz. So that quiz, since we're doing this flexible Friday thing, will be next week. All right, so for our first example here, all right, x to the fifth plus 32. All right, so what we want to do is we want to get x to the fifth by itself. Okay, so we're just going to subtract 32, and we get x to the fifth equals negative 32. All right, now, just like if it was x squared, in order to get rid of the squared, you would take the square root. In order to get rid of the fifth, we are going to take the fifth root of both sides. All right, and take the fifth root. Now, we have a negative under here. It is okay to have a negative because it's an odd root. If it was an even root, then this would be no solution. So if you look in these directions, we're solving under the real numbers, which means I don't want imaginaries here. If you get an imaginary, the answer is going to be no solution. All right, there isn't going to be an answer. Okay, so since it's an odd root, it's okay to have a negative under there. What is the fifth root of 32? Well, that is 2. So the fifth root of negative 32 is negative 2. So x is equal to negative 2. And there's our answer. All right, looking at number 2. Now, we have x minus 2 cubed equals 24. So here we wanted to get the x to the fifth isolated. Here we want all of this by itself. So if we have a quantity raised to a power, that is fine. Okay, we're not going to multiply this out. To get rid of the cubed, we are just going to take the cubed root of both sides. All right, what is the cube root of x minus 2 cubed? Well, it's just x minus 2. All right, and what is the cube root of 24? Well, it's not a perfect cube. All right, but 24 is what? 8 times 3, and the cube root of 8 is 2. If you had to break it down, it's 2 times 2 times 2. You could take out a 2. So it's 2 cube root of 3. All right, now, for these first couple, they've both been odd roots. If it was an even, like a square root or fourth root, we would have to do plus or minus. But when it's just an odd, you just do 1. All right, so then we just have to get the negative 2 in there aside. So it's x equals 2 plus, not plus or minus, just plus because it was an odd root. 2 plus 2 cube root of 3. All right, and there's our answer. Okay. Here, we just have x squared to 10. All right, this one is a nice easy one. We just have to take the square root of both sides. All right, square root of x squared is x. Since it's a square root or if a fourth root, any even root, you have to do plus or minus. So it's x equals plus or minus the square root of 10. All right. All right, going down to number 4. It is the 8th root. All right, so I would take the 8th root. Now, hopefully, you recognize, like, wait, I have an 8th root, which is even. I can't have a negative number in there. All right, which means there are no real solutions here. There are no real solutions. There's imaginary. There's this I. We're not even dealing with I because I is just with square roots. We're just not doing. We're doing real solutions. All right. So, I has to do with like the square root of -1, not the 8th root of -1. So we're not getting into any of that. All right. So it's just no real solutions for this. So if you ever have a negative number in an even root, it's just no real solutions. Okay. Number 5. Now for this one, this is what we need to get by itself first before we take the square root of both sides. So we need to divide by 2, and I get x minus 5 squared equals 7 over 2. All right. Now I take since it's by itself, I can take the square root of both sides, and I'm left with just x minus 5 equals the square. Now it's the square root, so it's plus or minus. All right, so it's plus or minus the square root of that, which is really the square root of 7 over the square root of 2. I don't like this color. All right, and to rationalize that, I multiply top and bottom by the square root of 2. All right, so I'm left with x minus 5 equals plus or minus root 7 times root 2 is root 14 over 2. And then I need to go ahead and just move that over here. So x equals 5 plus or minus the square root of 14 over 2. All right, there's your answer. All right. This one, we first need to add 1 to both sides, and we get x to the 4th equals 81. All right. All right, so it's x to the 4th equals 81. And then I'm going to take the 4th root of both sides. All right. And now 81. Hopefully you know that this is actually something that goes in evenly. Okay. But if you didn't, you could always break down. Remember, 81 is 9 and 9. All right. 9 is 3 and 3, another 3 and 3. So I have 4 of those. So 3 to the 4th is 81. So x equals 3, because the 4th root of 81 was 3. Now, since that is since this is a even root, we have to put a plus or minus. All right, so plus or minus 3 is your answer. And if I went and plugged that in, 3 to the 4th is 81, minus 1 is 80. If it's a negative 3 to the 4th is 81. 81 minus 1 is 80. All right, so there is your answer. All right, last one we're going to do is I wanted to show you one with a fractional exponent, a rational exponent. Okay, so we have x to the 2/3 is equal to 4. Okay, so what we're going to do, a couple of different ways you can do it, but this is the easiest way we're going to do it, is we are first going to raise both sides to whatever the denominator is. So we're going to raise it to the 3rd. All right, so what is x to the 2/3 times 3? Well, that is x squared. 4 cubed is 64. Now we have x squared. We can just take the square root of both sides, and you get x equals plus or minus 8. And there's our answer. Now, that way is probably the simplest way. Another way you could do it is you could do this. Let me just erase this real quick. All right. So that was kind of like 2 steps. If we kind of want to do it in 1 step, how could I get rid of this? Well, if I raise it to the reciprocal of this, 3 squared, what's 2/3 times 3 squared? 3 over 2. Sorry, 3 halves. 2/3 times 3 halves is just 1. So it's x equals 4 to the 3 halves. Well, what does 4 to the 3 halves mean? 4 to the 3 halves means the square root of 4 cubed. What's the square root of 4? 2. What's 2 cubed? 8. Same exact answer. Okay. I think it's probably easier just to do, some of you don't probably know, like simplifying these. So if you just raise it like we did at the beginning to the first part, whatever the denominator is, we cubed it, right? So we got x squared equals 4 cubed, which is 64. And then we took the square root, which is 8. All right. And, but in this case, problem with doing this way is you might forget that is a plus or a minus. All right. And that's where you run into issues. Okay. So if you do it the other way, you're probably not going to forget about the plus or minus. All right. So that's where we're going to stop right here. We'll do some of the other more complicated ones of these next time, along with dealing with radicals in the equation. All right. So I hope you guys are doing well. And you're going to use these notes to help do your assignment. It's not going to be very long. And then we'll pick up with this next class. All right, see ya.